This is the third and last part of lesson 3, debugging and troubleshooting your VIs. In this third part, we are going to create this exercise 3 uh, in order to understand how to create a Levy program VI. Okay, the requirement is a triangle should be valid. All three sides must have a length that is greater than 0. This is the Heron's formula that we have to apply, where AS is equal to A plus B plus C over 2. Let's try it. Let's make it. Alright, create a new VI, press Ctrl T. We need three sides of a triangle. So numeric control, three numeric control should be there. So this is side A and this is side B and this is side C. Alright, all three sides should have length greater than 0. In order to ensure that, go to comparison palette, select greater than 0 and drag it. Side B should be also greater than 0. Side C should be also greater than 0. Go to numeric, compound arithmetic, and this should be chain to end function. All these three sides should be greater than 0. So compound arithmetic should be end operation in order to ensure that all three sides are greater than 0. And we should take one boolean LED and name it validity of triangle. Alright, so in order to check it that all three sides are greater than 0, and default values for these exercises are side A should be 6, side B 8, side C 10. So make it 6. Enter 8 here and 10 here. How to make current value default? Go to data operation, make current value default, go to data operation, make current value default, go to data operation, and make current value default. Okay, let's verify up to now that all three sides are greater than 0 and that LED should glow. LED should eliminate because validity of triangle is true. Yes, the program is correct up to now. Let's move ahead. Now, as you know that S is equal to A plus B plus C divided by 2. So let's take compound arithmetic here. It should be performing the operation of addition, compound. So add is here. So this is side A, this is side B, and this is side C. Alright, so this is basically S, which is equal to A plus B plus C divided by 2. Alright, so go to numeric, take division. This is 8A plus B plus C divided by, create constant, divide by 2. Alright, and then now you know that in order to apply Heron's formula, which is equal to A is equal to root of S minus A, S minus B, S minus C. So take subtract function, copy it here in this way, left edges. Alright, so it should be ace minus a. This is ace. So this is ace minus a. This is ace minus b, and this is ace minus c. So this is ace minus a, whereas this one is ace minus b. These are free levels. This is ace minus c. Alright. Ace minus a, ace minus b, and ace minus c. Okay. Now we should multiply these all together. Go to numeric, compound, arithmetic. Multiplication should be in this way, that ace into ace minus a, ace minus b, ace minus c. Alright. Go change mode to multiply. First there should be ace. So this is basically ace. This is ace minus a. This is ace minus b, and this is ace minus c. And finally you should perform square root, under root on overall these. So go to numeric and search for under root. Okay, this is the square root. Perform square root on this, and right click here and create indicator here. Name this indicator is area of triangle. Alright. This should show area of triangle. Now as per our these calculation, this answer should be 24. Run it and test it. 6, 8, 10. And we are getting 16.97. It means there is some issue. Alright, let's look for the issue. That is the problem. This is ace. Yes, this is ace. This is correct. This is B. Okay, this is C. C is correct. Okay, here is the problem. This should be connected with D. This is S minus B, and B is this value, and this is B. This is B. Let's check this B. Now this is correct. Let's check this. This is C. Now this is correct, and it should now work properly. So we rectified the error, and now it is 24. So this is how you can create this program. Try it yourself as well in order to have a practice on Levy software. Now let's move ahead. This was additional activity. This was not the part of uh, Levy Code 1 training, but in order to have further grip on this topic, we tried to solve this activity by ourselves. So you should try it yourself as well. Now let's move ahead. So the question is, if you have a VI with broken run arrow, what should you do first? So if you have a VI with a broken arrow, go to the error list, see the errors, and try to troubleshoot the errors. After you fixed your broken run arrow, your VI results show unexpected data. What can you do next? If it is still showing unexpected data, again try some debugging tools. See, use pro function, use single stepping, execution highlighting, and other debugging tools in order to make sure that if there is any division by zero function, if any number is divided by zero, or if under root of any negative number is taken, or if there is any uh, incorrect value that is used, try to troubleshoot it by using again debugging tools. Okay, error cluster. All right. So we use error clusters in LabVIEW, and error clusters are used also as on input side and also used on output sides. And error cluster here is basically consists of three things: status, which is Boolean data; code, which is a numeric data; source, which is a string data. So with if its status shows that whether the error is there or not, and code shows that what type of error is present, and in number you can see the code relevant to that error, and then source description of the error is present. All right. If the status is true, that means that errors are available, and if errors are available, then your VI cannot execute. It will be broken VI, and code will be non-zero. If status is false, but the code is non-zero, that means some warnings are there. If there are warnings, your code will execute, but you should see that what warnings are available, so that in future you may not encounter some problem. Okay, the next concept is merge errors. Okay, basically the concept of merge error is the merge error function returns the first error found. Whatever the first error found, it will show it. If no error is found, it returns the first warning. So basically merge for error does not concatenate errors. It does not combine errors, but it shows whatever the first error LabVIEW encounters, it directly shows that error. So if there is no error, it will show the first warning. You should use merge errors to propagate errors along wires and merge errors from different wire paths. At the end of your application, after all error sources are merged into one error cluster, you must repeat errors to the user using the simple error handler VI or another error reporting mechanism. So this is the merge error function. Whatever the first error will be encountered, it will show that first error. It does not mean that merge error will concatenate the errors. No, it will not concatenate the errors, but it returns the whatever the first error is. All right. By default, the simple error handler VI, this is simple error handler VI, by default it displays a dialog with description of any errors that occurred and does not report warnings. However, the simple error handler VI can be configured for the error handling behavior. You can also see warnings here using the simple error handler VI. Alright, so let's have a lesson review now. Alright, in lesson review, our first question is, which of the following result in a broken run arrow? A sub-VI is broken. The diagram includes a divided by zero. A required sub-VI input is unwired. A Boolean terminal is wired to a numeric indicator. Alright. Yes, if the sub-VI is broken, it will result in broken run arrow. Option A is right. The diagram includes a divide by zero. No. It will show not a number. It will show an infinite number. It will show infinite number, but it will not show broken arrow. As we encountered in our exercise, that when you divide by zero, the broken run arrow, it will not show broken run arrow, but it will show unexpected result. So B is not right option. A required sub-VI input is unwired. Yes, if any required sub-VI input is unwired, it will show broken run arrow. A Boolean terminal is wired to a numeric indicator. Yes, We also studied that if two different data types are connected together, it will result in broken run arrow. So these three are correct options. Which of the following are components and data types of the error cluster? Status boolean, yes. We noticed that in an error cluster, it consists of three different data types. One was status and data type was boolean. A is the correct option. Error string, no. Error string is not the right option. Code, yes. 32-bit integer, yes. Code was shown. 32-bit integer numeric data was used. And source, yes, there was source type description of error, and that is basically data type string. So these three are correct options. Are errors have negative error codes in all warnings have positive error codes? No, false. It's false. Merge error function concatenate error information from multiple sources. No, it's false. Merge error function does not concatenate error information from multiple sources. It shows you whatever the first error is. If there is no error, it will show the warning. So this is false. Thank you very much. We have completed lesson 3. In our next video, we will continue our lesson 4. Thank you very much.